things on trigonometry. Okay, this is very important to remember. Okay. So let us say these are my 4 quadrants. Okay, so this is 0 degree, this is 90, and this is 180, and this is 270. Okay, so this is my first quadrant, this is my second quadrant, this is my third quadrant, and this is my fourth quadrant. Okay, so all sine, cos, tan, cot, sec, cosec, all these angles will be positive in the first quadrant. Okay, and then only sine and cosec will be positive in second quadrant. Sine and cosec will be positive in second quadrant. Okay. So what does it mean? Like say sine 120. Okay. Sine 120 is equal to sine 90 plus 30, which is equal to cos 30, right? Sin 90 plus theta is equal to cos theta, which is equal to cos 30, which is equal to root 3 by 2. Okay. So sin 820 is equal to cos 30 equal to root 3 by 2, which is positive in the second quadrant. But if you consider cos 120, you have cos 90 plus 30, which is nothing but cos 90 plus theta formula. Okay. Cos 90 plus theta is minus sin theta, or minus sin 30. So, which is equal to minus half. Okay. So, cos 120 is negative. So, like that. So, sine and cosec are positive in second quadrant. Everything else is negative, right? So, that's another thing. Then in the third quadrant, only tan and cot are positive. Okay. So, this is positive. These two positive, sine and cos. Then tan and cot are positive in third quadrant. Only tan and cot. Everything else is negative. Okay. Then in the fourth quadrant, cos and sec are. So here sine cosec, here cos sec in fourth quadrant. Cos sec. So these things are positive. So just remember, in first quadrant all 6 are positive. In second quadrant, sine and cosec. In fourth quadrant, cos and sec. In third quadrant, tan and cot. Okay. So this is important. This formula, sine 90 plus theta is equal to cos theta, whereas cos 90 plus theta is equal to minus sin theta. Okay. Then some important things we need to remember, like sine 90 minus theta is equal to cos theta. Okay. So any 90 minus theta is always positive, but the opposite too. It will be opposite. So because in first quadrant everything is positive. So sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta, and then tan 90 minus theta is equal to cot theta, just the reverse. Okay, cot theta means just the complement. And then cot 90 minus theta is equal to tan theta. Okay, and then sec 90 minus theta is equal to cosec theta. Cosec theta, and cosec 90 minus theta is equal to sec theta. So these are all positive because this 90 minus theta means it is in first quadrant, right? So in first quadrant everything is positive. So this is one about first quadrant, that is 90 minus theta. But 90 plus theta. So this is for 90 minus theta. 90 plus theta is a bit tricky. Only like say sine and cosec they are Okay, so sine 90, but it will become the complementary one. Okay, sine 90 plus theta is equal to cos theta. Okay, but cos 90 plus theta is equal to minus sin theta. One to be noted. Okay, so this is sine, then sine cos, then tan 90 plus theta is equal to minus cos theta. Everything else is negative, right?
Yeah.
Minus cos theta. Cot 90 plus theta is equal to minus tan theta. Then sec 90 plus theta is equal to minus cosec theta. And cosec 90 plus theta, this is positive, okay, sin theta, right?
Yeah.
So sine, these two, sine and cosec, these two, because that is about 90 plus theta. And there is a formula related to 180 minus theta, okay. So 180.
That will again be sin cosec positive.
So this is the yeah. So this is 90 plus this is, so this what we have done is 90 plus theta. Okay, this is 90 plus theta. This is 90 minus theta. Like there is something called 180 minus theta. So 180 minus theta is again the second quadrant, right? Okay, but here it will be not be complementary. It will be the same. So sin 180 minus theta is equal to sin theta, right?
Yeah.
And cosec 180 minus theta is equal to cosec theta. Just remember when 180 comes into picture, the sin will be the symbol will be same. Sin remains sin, cosec remains cosec. So so every other thing, cos 180 minus theta, tan 180 minus theta,
Yeah.
cot 180 minus theta, and sec 180 minus theta. So everything is, these are all minus. Okay, minus cos theta, minus tan theta, minus cot theta, minus sec theta. So these are related to formulas related to 180 minus theta. Okay, so these are the major things you should remember. Then there are certain things like 270 minus theta, 270 plus theta. So their sign will become cos. But you don't need to remember so many things. Just remember these few things. So when any angle more than 90 will come, you can easily do. See, up to 90 you can remember. Up to 90 you are remembering. No? Like say, I know my 0, 30, 45, 90. So up to this we need to remember. Let us say my sin 0 is equal to 0 I know, sin 30 is equal to half I know, sin 45 is equal to 1 by root 2 know, sin 90 is equal to 1. Okay, so then cos 0 is equal to 1, cos 30 is equal to
3 by 2.
sorry, I have to remember 60 also, right? 60 is root 3 by 2, then 90 is 1. So this is the formula for sine. Okay, for cos 0 is equal to 1, just the reverse. Okay, then cos 30 is equal to root 3 by 2, then this remains the same, 45, then this is half, and this will be cos 90 is equal to 0. Okay, so this is cos. Then tan is sine by cos. Okay, so this will be 0, and then what will become? This will be root 1 by root 3, right? That by that. Okay, then tan 45, 1 by root 2 by 1 by root 2, 0.
No, 1.
Sorry, 1. Sorry. Yeah, so 1. So tan 60 is equal to root 3 by 2, right?
No, only root 3.
Oh, sorry, root 3. And infinite. Okay. So these are the things you should remember. Only this much if you remember, and that this should be enough. Okay. You can take a picture of this. So this.
Not only I'll take picture. Side.
Okay. You again you
No, no, no.
video did not get paused.
Yeah.
It
Did not get paused.
Okay. This, 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 this. Okay. So this much, if you remember, it should be enough. Okay. Any angle more, it is easy to it. You have to by heart up to 90 degree. Beyond that, you have to use these formulas. Okay.
Yeah.
Okay. There are few more things. Okay. Yeah, so this conditional identity, there are few more things here, like sine 2a plus sine 2b plus sine 2c. Okay, so this formula you have to remember, which is being derived as 4 sine a, 4 sine a into sine b into sine c. Okay, so similarly, cos 2a plus cos 2b plus cos 2c is equal to -1 minus 4 cos a into cos b into cos c. So these things you have to remember. One very interesting thing is tan A plus tan B plus tan C. Tan C is equal to tan A into tan B into tan C. This is for tan. Okay. And then sin A plus sin B plus sin C is equal to 4 cos A by 2, 4 cos A by 2, cos B by 2, cos C by 2. So these are some interesting formulas you need to remember. Okay. Sin A plus B. Then cos A plus cos B plus cos C is equal to 1 plus 4 sin A by 2 sin B by 2 B by 2 sin C by 2. So these are some of the important formulas one should remember. Okay. These are called conditional identities. Okay. And then summation of some trigonometric series. Okay. So these are conditional identities. Conditional identities. Conditional identities. Okay. So this you have to remember because there can be questions on this. If you remember only, there is no time to derive actually. Okay. Okay, so some important things are like what will be the maximum value of certain things. Okay, max and mean values. Okay, max and mean values. Okay. So these are like sin x will vary from -1 to
Range
1.
and domain of trigonometry.
Range and domain. Yeah. So sin x will vary from -1 to 1.
Cos from 0 to pi.
Cos will vary again.
No, sir. This is not
-1
inverse. Not
-1 to 1.
cos x.
Sorry, cos x. So these are cos x. Okay. Then sec x is always greater than 1. Remember, sec x is always greater than 1. Okay, always positive. Cosec x is always positive. Okay, so always greater than 1, not positive, always greater than. And tan x and cos x take all real values. So tan x and cot x take all real values. Means it goes up to infinity, right?
Yes.
Minus infinity to plus infinity, whatever. So tan and cot, it will take all real values. Whereas for sine, cos, sec, cosec, these are the limit. Okay. Then maximum value of a cos theta plus b sin theta. So a cos theta plus b sin theta, what will be its maximum value? The solution is a square plus b square square root. This is the maximum value of a cos theta plus b sin theta. Okay. Similarly, minimum value, so this is max. Okay. Then minimum value of a cos theta plus b sin theta is equal to minus a square plus b square square root. Okay. And maximum value of a cos theta plus b cos theta, b sin theta plus c. What is the max? Max value. The max value of a cos theta plus b sin theta plus c is equal to c plus a square plus b square square root. Okay. So these things you have to remember, no other go. Okay. Then this is max, then mean value of a cos theta plus b sin theta plus c is equal to c minus square root a square plus b square. So these are some of the things we have to remember. Okay. Then summation of some trigonometric series. Okay. Some trigonometric series, what are their summations? Okay. So sin alpha plus beta plus sin alpha plus 2 beta. Okay, so
I'll take picture.
okay. Summation of trigonometric series. Okay. And some trigonometric series. Summation. Okay. So sin alpha plus sin alpha plus beta plus sin alpha plus 2 beta. It goes on till sin alpha plus n beta, right? If it goes on like this, the solution will be, the right hand side will be sin n beta by 2 divided by sin beta by 2 into sin alpha plus n minus 1 into beta by 2. So this is my formula. This you have to remember. Sin alpha plus n minus 1 into beta by 2. Okay. This is for sin. Similarly for cos. Okay. So cos alpha plus beta plus cos alpha plus 2 beta plus cos alpha plus 3 beta. Likewise it goes on cos alpha plus n beta is equal to sine. So sine by sine. So here also sine. So this is sine n beta by 2 divided by sine beta by 2. Then other side it will not be cos but it will be sine. Okay. Cos alpha plus n minus 1 into beta by 2. Okay. So this is the. So these things you have to remember. This is series in trigonometry. Okay. So that's all about trigonometry. So we can. So that's all about trigonometry. Only thing is you have to remember lot of formulas in trigonometry and practice as much as possible. So what are important, like the important from exam point of view is sine 2a, cos 2a, tan 2a, sine 3a, cos 3a, tan 3a. These formulas you have to remember at any case. Similarly, sine a plus b, cos a plus b, sine a minus b, cos a minus b. These are the things we have to remember, no other go. Okay. Like say sine 2a is equal to tan 2 tan a divided by 1 plus tan square a, cos 2a is equal to 1 minus tan square a divided by 1 plus tan square a, tan 2a is equal to 2 tan a divided by 1 minus tan square a. So sine 2a is equal to 2 tan a by 1 plus tan square a, whereas tan 2a is equal to 2 tan a minus divided by 1 minus tan square a. Similarly, cos sine 3a is equal to 3 sin a minus 4 sin qa. Cos 3a is equal to 4 cos qa minus 3 cos a. Cos 3 is equal to, so sin 3 is equal to 3 sin a minus 4 sin qa. Cos 3 is equal to 4 cos qa minus 3 cos a. Okay. Then tan 3 is equal to 3 tan a minus tan qa divided by 1 minus 3 tan qa. So these 2a, 3a formulas are very, very important. Similarly, sin a plus b, sin a minus b, cos a plus b, cos a minus b, tan a plus b, tan a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Okay, so those things are very, very important. Okay. Similarly, the other one like sin 90 plus theta, like in which quadrant, which one is positive. Based on that, 90 plus theta, 90 minus theta, sin will become cos. Then looking at the quadrant, you can decide which is positive and negative. So only all are positive in first quadrant, and cos and sec, sine and cosec.
Sine and cosec are positive.
Sine and cosec are positive in second, cos and sec are positive in fourth, tan and cot are positive in third. So that is 90 plus theta, 90 minus theta, 180 plus theta, 180 minus theta. That you have to remember. 90 plus theta or 90 minus theta, it will become the complementary one. Sine become cos. But 180 plus theta or 180 plus theta or 180 minus theta
remains the same.
It will remain the same. It will be the same. So those are the summary. Okay. Okay, fine. Okay, so today we will quickly go through the chapter on trigonometry. Okay. So it is in your class 11, but yeah. So it is so class 11 and 12 both are required. So we are just quickly go through trigonometry. Okay. So let us. So what we will cover is angle on circular system, trigonometric functions, trigonometric identities, and then trigonometric equations and summation of trigonometric series and all that. Okay. So let us first start with angle on a circular system. Okay. Angle on a circular system. Okay. So if you have a circle, if you have a circle of radius r, and if you have a arc of length l, okay. So this is your radius. Okay. So this is part of a circle. So this is your angle theta. Okay. So this is your angle theta. So this is your length of the arc is L, and your radius of the circle is R. Okay. So if this is the case, the angle subtended by this arc is theta. Okay. If that is the case, then tan theta, theta is equal to L by R. Theta is equal to L by R. Okay. Then theta is, so what is the angle in case of a circular system? That is the R divided by the radius. Okay. So if the angle, if the length of the arc is equal to the radius of the circle, then angle subtended at the center of the circle will be 1 radian. So when L is equal to R, when theta is equal to 1, right? It is L by R, so it is 1. So when L is equal to R, that implies theta is equal to
1
unit or 1 radian, that we call 1 radian. Okay. So the unit measure of angle is radian here. Okay, 1 radian. Okay. So 1 radian, how do we write? So in your calculator you have two things, 1 radian, radian and degree. So you write it as 1 radian. Okay. See, this 1 radian is something around 57 degree 16 minutes. So 1 radian is equal to 57 degree something like 16 minutes or so. So that you have to remember. Okay. Then usually we know 2 pi radian is nothing but 360 degree.
Yeah.
Okay. So 2 pi radian is equal to 360 degree, or otherwise we know pi radian is equal to 180 degree. Okay. So pi radian, you know pi is nothing but 3.14. Okay. So 3.14 radian is equal to 180 degree. So that implies 1 radian is equal to 180 divided by 3.14, which is nothing but 57 degree 16 minutes. So that's how the conversion goes. So if you want to convert radian into degree, that is the conversion. Like in your calculator, you will have two options. You want the angle in radian or in degree. So suppose you get an angle as like say 179 degree. That means that 179 you have to divide it by 57, and then you will get degree. It will get converted to say whatever. Let us say this is x radian.
It will be in radian.
Yeah. So it's whatever you will get, that is the. So you are converting a angle in degree. If you divide it by 57, then you will get angle in radian. Okay. So now you know, like the first thing, angle on circular system. It is clear now?
Yeah.
Okay. So yeah. So normally they say 2 pi radian is equal to 360, pi radian this, 1 radian is this. Okay. You can take a snapshot of this. Then we will start at trigonometric functions. So we have angle on circular system. Then we will have trigonometric functions, and then trigonometric equations. Okay. So we will have trigonometric functions and trigonometric equations. And then first we have covered like what is in a circular system, how do we calculate theta in a circular system. Done, no? So how do you calculate angle in a circular system? The relationship between radian and degree. So if you divide angle in degree divided by 57, so you will get angle measured in radian. So pi radian is equal to 180 degree and 2 pi radian is equal to
360
degree.
Okay. Then we will get into trigonometric functions. So let us draw a circle. Okay. Kind of let us draw a circle. Okay. So it is kind of x, x dash, y, y dash. This is my okay center. Okay. So taking y center and let it be having unit radius. Okay. So this is my radius and this is having unit radius. Okay. Just there's a cutting the coordinates axis at A, B, and so it cuts the coordinate axis at A dash, B, B dash. Okay, so these are my coordinate axis, and the circle cuts it at these 4 points. Okay, so let PXY be any point on the circle. Okay, so let this point be P, which is any point on the circle. Okay. So, okay. So this is my angle theta. Okay. So this is my angle theta. So here AOP. So this is O actually. So AOP. This angle is nothing but theta, right? And then you can have its x and y projection of this. So let this be r. Okay, let this be r.
R
So,
cos
yeah. So this is my y, and let us say this is my x. So these are the projection on the x and y axis. Okay, so that is then. How do we define different angles like sine, cos, tan, cosec? So how do we define all these? Okay. So then the 6 trigonometric functions. So what are trigonometric functions? So trigonometric functions are sine, cos, tan, cot, sec, cosec. So how do we define these functions? Like say cos theta in this case actually.
x by r.
Yeah, so this point is M actually. Okay, so this point is O and this point is M. So your cos theta,
OM by OP.
cos theta is equal to OM by OP is equal to
X
your
by
x
R.
by R. Okay. So x by R. Okay, so similarly sin theta is equal to your
L by R.
MP. Okay, MP by OP, right?
Yeah.
OP is equal to y by R. Okay, so this is your sin theta. Then sec theta. Okay, so sec theta is just inverse of 1 by cos theta. Okay, so is r by x. Okay, r by x sec theta. Okay. Okay, so this is my sec theta, cos, sin, sec theta, and then cosec theta. Cosec theta is equal to 1 by sin theta, so that will become r by y. Similarly, you have a tan theta. Okay, so your tan theta is equal to y by x. Okay, your y by x. Okay, and then your cosec theta, cot theta. Cot theta is equal to x by y. So these are different trigonometric functions. Okay. Then there are something called trigonometric identities. There are many things in trigonometry you have to remember. Otherwise, we cannot go on deriving formulas. Okay. So what are trigonometric identities? Trigonometric identities. So one is sine square theta plus cos square theta is equal to 1. That is one trigonometric identity. Then another one is sec square theta minus tan square theta is equal to 1. If you want, I can derive it.
No need.
Okay, so then third one is cosec square theta minus cot square theta is equal to 1. Minus cot square theta is equal to 1. So these are my three trigonometric identities for proving many things. You need to remember all these identities. Okay. And then using trigonometric function of acute angle. So trigonometric ratios as function of that we have shown in a circle. So if we show trigonometric functions, trigonometric ratios of acute angle. Okay. So trigonometric functions of acute angle. Trigonometric functions of acute angle. Okay. So, and that is you know already. So let us say this is my triangle. This is my triangle. So this is my acute angle. This is a right angle triangle. Okay. So, so if this angle is theta.
Same thing.
Same thing. So A, B, C, A, B, C. So this one you call base. So this is base. Okay. So then this is your perpendicular. So this is known as B. This is your P or perpendicular. And then this is called hypotenuse. Okay. This is the H. Okay. Hypotenuse. Okay. So this is B, H and P. So so the same thing holds good here. Like whatever we have written here, like say cos theta is equal to B by H, right? Base by height.
Yeah.
Sin theta is equal to P by H. Okay. Then sec and cosec are just reverse, and tan theta is equal to your H by B, right?
Yeah.
Y by X or H by B. Cot theta is equal to just reverse of tan is B by H. So these are so now we have covered trigonometric identities and trigonometric functions of acute angle. Okay. So you take a picture of this, then you will go to the next one. See, this looks very simple, but we have to remember this. These may look very simple, but when for a long time I left these things in engineering, when we use it frequently, so we tend to forget this. These simple things also we tend to forget because we'll lose touch and we tend to forget. Okay, then sign of trigonometric ratios in 4 quadrant. Okay, so and that we'll do it later. Okay, that's not a problem. Then we'll do some related to compound angle. Okay, compound angle. Compound angle. Okay, so what is a compound angle? These formula also we can derive, but I am just writing it down so that sin A plus B is equal to, let's say, sin A into cos B plus cos A into sin B. Sin cos, that is a combination. That's how we remember. Sin cos A B, sin cos cos sin. That is sin A plus B. Okay, sin, and both are positive. Sin A minus B, a minus sign will come into picture. Okay, sin A into cos B minus cos A into sin B. it is sin A minus B. That's the formula. Similarly, cos A plus B, both A and B will be cos
Cos
B.
will be.
Okay, cos A into cos B, and it will be minus. In case of
Yeah.
cos, it will be minus.
Yeah.
Cos A into cos B,
Into
it is
sin
sin A
A
into
into
sin
sin
B. Okay, then sin
Cos
cos A minus B.
Same thing with the plus.
So it will be cos A into cos B
Plus sin
plus
A
sin A into sin B. So this is about cos. Okay, then tan A plus B, you can derive using these two, but after derivation, let me write down the formulas only. So these will help to derive this tan A and all. Okay, so tan A plus B is equal to tan A plus tan B. You have to remember this, no other way. 1 minus tan A into tan B. So that is the formula for tan. Okay. Then cot A, tan A plus B, then tan A minus B. Tan A minus B is equal to. So you just remember, in case of tan, it will be positive. In case of sine, it will be positive. So that there is a relationship between the sine and tan. In the numerator, it will be positive. If it is in the numerator positive, denominator negative. So tan A minus tan B divided by 1 plus tan A into tan B. So this is tan formula. Okay. Similarly, cot A plus B. Okay. So this is, it will be bit reverse. Okay. Cot A plus B. Okay. So you just reverse it. This will reverse it, but you have to write it as cot.
In terms of cot.
So cot A plus B is equal to cot A into cot B minus 1 divided by cot A plus cot B. Then cot A minus B is equal to cot A into cot B plus 1. Cot A into cot B plus 1. So this cot you can see in case of here it is minus, but here it is plus. Okay, in cot the numerator A plus B, it will be minus, and this that you have to remember. Okay, cot cot A minus B, cot B minus A, cot B minus cot A. So these are the formula for cot A minus B. Okay. Then another important formula is tan for pi by 4, tan pi by 4 plus A is equal to 1 plus tan A divided by 1 minus tan A.
Yeah, because tan pi by 4 is 1.
Yeah. So this you can get it from here.
Because tan pi by 4 is 1.
So here you replace tan pi by 4 and A. Okay. And then tan pi by 4 minus A is equal to tan pi by 4 minus A is equal to 1 minus tan. Okay.
1 plus 1.
So you can see this minus means here and this plus plus. In case of tan, it will be plus. So 1 minus tan, 1 plus tan. So these are formulas on compound angle. Okay, you can take a picture of this. Then we will go to multiple angle. So these you have to by heart all these things. You cannot derive it. So this is about compound angle. Then we will get into multiple angle like tan 2A, tan 3A, sin 3A, cos 3A, those things. So you see, there can be in your JE and all. It's all about practice. Okay. So if you remember this formula, like then only you will be able to do little bit complicated things. Okay. So we will get into multiple angles. Multiple angles. Okay, multiple means multiple 2A, 3A and all. Okay. So see, this sine 2a is nothing but sine a plus a. Okay. So by using sine a plus b formula only you can derive it. So but you don't have that much time to derive. So you have to remember it.
2 sine a cos.
Yeah. So it will be 2 sine a into cos a actually. Cos a. So this finally it will, in terms of tan, it will become 2 tan a 1 plus tan square.
Tan square.
So if you want to write in terms of tan, this is the formula. Okay. And then cos 2a is equal to
1 minus cos square.
1 minus tan square a divided by 1 plus tan square a. So that is cos 2a in terms of tan. Okay. Then you can write it as 1 minus 2 sine square a. If you want to write it in terms of sine. Okay. 1 minus
cos square a minus 1.
Yeah, so again it is also same as cos square, because by using cos a plus b formula you can get it. So it is nothing but cos a plus a. So it will become cos a into sin b, sin a into cos b, a cos a into cos b minus sin a into sin b. So it will be what? It will be cos a into cos a minus sin a into sin a, right?
Yeah.
Minus sin a into sin a. So this becomes cos square a minus sin square a. So if you want to write it in terms of sine, so cos square is equal to 1 minus sin square a minus sin square a. So this becomes 1 minus 2 sin square a. Okay, so this is how you have to remember all these things. Okay, then this is your cost. Then there is a
And
formula for.
you can put sine square a as also 1 minus cos
Yeah.
square a, and it will become 2 cos square a minus 1.
Yeah. So then this is about 2a, then tan 2a. Okay. If you know these three things, you can do other three. This is just the reverse. So tan 2a is equal to 2 tan a by 1 minus tan square a.
Yeah.
1 minus tan square a. Okay, then this is about 2a. These are called multiple angles. So now 2a. Now we will get into 3a. Okay, so sin 3a. Sin 3a is equal to 3 sin a. 3 sin a minus. It's the same by using those a plus b and all. We can do it. 3 sin a minus 4 sin qa. So you have to remember these things because there will be MCQ questions on this. Okay. So sin 3a is equal to 3 sin a minus this. Then cos 3a is equal to 4 cos qa minus 3 sin square a. Just see how the similarity between these formulas. Okay. So then there is something called tan 3a. Tan 3a is equal to 3 tan a minus what is written? Tan qa. Okay, 3 tan a minus tan qa divided by 1 minus 3 tan square a. So these are formulas for multiple angles. You can take a picture, then you will go to the transformation formula. Okay. This is about multiple angles. Okay. Then there are some formulas like sine C plus sine D. Okay. So sine C plus sine D. Okay. Earlier we had done sine A plus B. But sine C plus sine D is transformation, and this is equal to 2 sine C plus D by 2
by 2. Half formulas.
into cos C minus D by 2. Okay. This is formula for sine C plus D. Okay. Similarly, there are formula for sine C minus sine D. Okay. So sine C minus sine D is equal to 2 cos C plus D by 2 into sine C minus D by 2. Okay. So these are formula for sine C, sine D and all. Okay, then another formula is sine A plus B into sine A minus B. Sine A plus B into sine A minus B is equal to sine square A minus sine square B. That you have to remember. Okay? This is important. Then cos A plus B into cos A minus B. Cos A plus B into cos A minus B, again cos square A minus cos square B. Okay. And there is a formula that may be important one. Cos A into cos 2A into cos 4A into cos 8A, cos 4A into cos 8A, cos 8A, like this. If you go on like this, and then at the end if you have cos 2 to the power n minus 1. Okay. So this is cos 2 to the power 0. It started from 2 to the power 0, then it goes on till 2 to the power n minus 1 and a. Okay. So this result of this is 1 by 2 to the power n sin a. Okay. So there are n terms. So 1 by 2 to the power n sin a into sin 2 to the power n a. Okay. So this is the formula. 1 by 2n sin a into sin 2 to the power n a. So n is nothing but your last term is n minus 1 term. Okay. So you can find out what is your. Suppose there are 1, 2, 3, 4 like this. There are so in the example they will give. Okay. Suppose you want to find 1, 2, 3. These three only. Suppose somebody is asking you what is cos a, what is cos 2a into cos 4a. Okay. So cos 4a. So yeah. So this is cos 2 to the power 2, cos 2 to the power 1 into a. So your n is equal to 3 here. Right. So if your n is equal to 3, the formula here, this will be equal to 1 by 2 to the power 3 sin a into sin again 2 to the power 3, which is 8. Okay. So 1 by 8 sin a into sin 8a. That is the answer. Okay. So like this, this is an important one which may come. Okay. So you can take a snapshot of it, then we'll go to the other things. So you have to remember all these things and practice as much as possible. Okay. See what are the different CET questions or JE questions, what and all are coming. So accordingly you can do. Okay. And there are some important